Good morning, students. So once again, I welcome you all for this session. Okay. So in previous session, we have studied the the different aspects of a force. Okay. Now let us move on to we have studied classification of force system. Okay, that is coplanar, non-coplanar, concurrent, non-concurrent force system, collinear, then parallel, that is like parallel and unlike parallel force system we have studied. Next, move on to the another important aspect of this engineering mechanics, that is movement of a force you know already. Okay, it is an external agency which will going to change the state of the object. Now what is a movement? Okay, see the term movement. Okay, it is not movement, movement, not, it is movement, moment. So what is this moment? So here onwards, whenever you come across with the term moment of a force, is nothing but it is a rotation. Moment is nothing but a rotation. Okay, so the capacity of a force, okay, the capacity of a force to produce rotatory motion in the object is called as moment of a force. Okay, so when you apply the force, okay, so when this force, if the force rotates the object, then you can say that there will be a moment of a force. So moment is nothing but a capacity of a force to produce rotatory motion is called moment of a force. Or in also it is termed as moment is defined as, or how to calculate the moment. Moment is defined as the product of magnitude of force and perpendicular distance of the point from the line of action of force. So if you want to calculate moment, two things are required. One is force is required and the perpendicular distance is required. Okay, perpendicular distance between the point and the line of action of the force, then only there will be a rotation. Okay, if there is no perpendicular distance, then no rotation will be there, moment will be zero. Okay, so moment is nothing but it is the product of, or it is a two terms, product of two terms, that is one is magnitude of force, that is F, into perpendicular distance between the force F and the point where you are calculating the moment. Now take example. Okay, so let us define these two terms first. What is a moment center? Now see, consider this is a body, rigid body, right, which is subjected to force F. So whatever you are seeing, this is the applied force F. Now I am going to select 3 points. This is point 1, point number 2, and this is point number 3. Now see, what is this D1? D1 is nothing but perpendicular distance. Okay, it is a perpendicular distance between this force F and point 1. Okay, this is a perpendicular distance D1, and D2 is perpendicular distance between same force F and point 2, and there is no perpendicular distance for point 3 because point 3 is lying exactly on the line of action of the force. Okay, so D1, D2 are the perpendicular distances of point 1 and point 2 from force F. Now what is this term moment center? Okay, the point about which, okay, the point about which the moment is considered or calculated is called as moment center. Now see, in this sketch I want to calculate what is the moment of this force F. Okay, moment of this force F about point 1. I am going to calculate what is the moment of this F about point 1. So means point 1 is nothing but moment center. Okay, similarly I want to calculate moment of this force F about point 2. So point 2 is also called as moment center. Similarly I want to calculate moment of this force F about point 3. So point 1, point 2, point 3, so on. These are called as moment centers where we are calculating the moment, or we are considering the moment of a given force. Then moment arm. As you know, to rotate the body or to to produce a moment, there is a perpendicular distance is required. Okay, perpendicular distance between the force and the point where you are considering. So between those 2 points, if there is a perpendicular distance, then only the rotation will be there. Okay. So moment arm is nothing but the perpendicular distance of the point from the line of action of the force is called moment arm. Now see, 1, 2, 3, these are the moment centers, and D1, D2 are nothing but the moment arms. So D1 is moment arm for this force F and point 1. So perpendicular distance between force and the point where you are calculating, that is called as moment arm. So D1 and D2 are the moment arm. Okay. Now next, again consider this sketch in which D1, D2, right, are the perpendicular distances from force to the point 1, 2, etc. Now moment of F, now we are going to calculate one by one. Moment of this force F about point 1. Okay, moment of this force F about point 1 is given by, so remember, capital M indicates moment now. Capital M here onwards, whenever we write capital M, it is nothing but a moment. So moment at which point we want? We want to calculate at first point. So moment of this force F about first point. So M is moment about 1, that is M1 is equal to, moment is what? Force into perpendicular distance. Okay, so force into perpendicular distance. Now consider this. What is the force now? Magnitude of force is F. Okay, force is F and perpendicular distance between force and where you are calculating? You are calculating at 1. So what is the perpendicular distance between F and 1? It is D1. So M1 is equal to F into D1. So force into perpendicular distance between F and point 1. So similarly, moment of this force F about 2. Okay, again force into perpendicular distance. Force is F only and perpendicular distance between this F and 2 is D2. So M2 is equal to, that is moment about 2 is equal to, force is F into perpendicular distance between F and 2 is D2. So F into D2. Similarly, what is the moment of force F about 0.3 now? Force is F. Force is F, and what is the perpendicular distance between F and 3? Okay, so this 0.3 is exactly on the line of action of this force F. There is no perpendicular distance between this force and 3. Suppose if 3 is here, then this will be the perpendicular distance. But 0.3 is exactly on the line of action of force, right? There is no perpendicular distance between F and 3. So M3 is equal to, force is F, perpendicular distance is 0. No perpendicular distance. So moment will be 0. M3 will be 0. Means about this point, this body will not going to rotate. But if you see, what is M1? M1 is equal to F into D. M1 is equal to F into D1. So this will going to rotate like this. About point 1, this will going to rotate like this. Then about point 2, this will going to rotate in this direction. So but about point 3, it will not going to rotate because there is no perpendicular distance. So moment will be 0. So remember, if you want to calculate moment, so you require two things. One is magnitude of force and another will be perpendicular distance between the force and the point where we are calculating the moment. Okay, that is F into perpendicular distance. So the moment of a force has got direction also. Normal, we say that moment is nothing but the rotation. There will be two possibilities. One is the body may rotate clockwise or the body may rotate anti-clockwise. Only these two possibles. No horizontal movement. No horizontal movement, no vertical movement. Okay, only the body will going to rotate. Moment means it is a rotation. Either it is a clockwise rotation or anti-clockwise rotation. Now see, in this case M1, whatever you have calculated, M1 F into D1. Now see, moment of this force about 1 is F into perpendicular distance. Now with reference to 1, if you move on to this force, So this will going to rotate like this about 0.1. So this is the rotation, that is clockwise. Okay, this is clockwise. So M1 is clockwise moment. M1 is called as clockwise moment, and M2 moment about this is force into perpendicular distance with reference to point 2. Now move over this force. This will going to rotate like this about 2. Okay, this will going to rotate anti-clockwise. So M2 is M2, that is force F into D2 about 0.2. This will going to rotate anti-clockwise. So anti-clockwise means minus or negative. Okay, clockwise rotation means positive. So body either rotate clockwise or anti-clockwise. If it is clockwise movement, if it rotates clockwise, it is called as clockwise movement and it is indicated as positive. If the body rotates in anti-clockwise direction, then it is anti-clockwise moment, it is considered as negative. So M1 is positive, M2 is negative, and M3 is 0 only. There is no question of positive or negative. So like this, you have to calculate the moment about force at any point. Okay, now next important thing is unit of moment. So moment will be measured in terms of a particular unit. Then what is the unit of moment? Now see, what is a moment? It is a force into perpendicular distance. Means there are two terms. Force is there and perpendicular distance is there. So the unit of moment will going to depend on the unit of force and unit of distance. Okay, whatever the force unit will going to take and whatever the distance you will going to take, so depending upon that unit of moment will be there, because moment is force into distance. Now see, if the force is taken in Newton, okay, and the distance is in meter, then what will be the unit of moment? It is force into distance. So force is Newton, multiply by distance is meter, so Newton meter. Okay, so unit of moment will be Newton meter. Suppose if the force is in kg, force you are taking in kg and distance is in centimeter, perpendicular distance is in centimeter, then what is the unit of moment? Kg centimeter. Okay, it is not kg per centimeter, it is kg centimeter, like this. So unit of moment will going to depend on unit of force and unit of distance. Okay, then so understand this concept very clearly, because we are going to solve the problems on moment, calculation of moment, and this is the important problems we will going to get in the examination. Okay, so moment is nothing but it is the capacity of rotation of, right, or it is the capacity of a force to rotate the body. Okay, to produce moment, what is required? Magnitude of force is required and perpendicular distance is required. So moment is equal to force into perpendicular distance between the force and where we want to calculate the moment. So unit of moment depends on, okay, unit of force and unit of distance. Okay, next move on to the next term, that is couple. As you already aware of this term couple. So what do you mean by couple? Now see the sketch. There are two forces, right, of same magnitude. This is also F, this is also F. But interesting thing is these two forces are parallel to each other. Okay, parallel to each other and opposite in direction. See, these two are parallel, okay, and they are opposite in direction, and these two forces are separated by a distance d. Okay, so now if you move over these forces, now see, move like this. So there is a rotation, okay, either this rotation or sometimes anti-clockwise rotation also. So if you want to form a couple, this is called as couple. Now rotation is couple. So if you want to form a couple, what is required? So two forces are required of same magnitude. Okay, magnitude should be seen. If it is F, then this should be F only. If it is F1, no. If it is 5 kg, if it is 6 kg, no. Right? So both the forces must be same magnitude, opposite in direction. then separated by perpendicular distance, and these two forces must be parallel, then only there will be a couple. So two parallel forces equal in magnitude and opposite in direction separated by a definite distance are form a couple. So then only couple will going to form. Now if you add the forces, now this is F in this direction, this is F in this direction. Suppose if you take this is plus F, this is minus F. So what will going to get? They will going to get cancel. Okay, they will going to get cancel. So the sum of forces forming a couple in any direction is 0. Okay, this is plus, this is minus. What it indicates, which means the translatory effect of the couple is 0. Okay, what do you mean by translatory? So the effect of this couple, okay, there is no horizontal movement, there is no vertical movement. Okay, these two are 0. So these two are called as translatory motion. Okay, horizontal direction, vertical direction, there will not be moment. So that is 0. Only possible is again a rotation. So which means the translatory effect of a couple is always 0. So only there is a rotation. Then again, just like a force, you can find out the moment about force any point. Similarly, we can find out moment of a couple. So this is a couple, I can find out moment of this couple about any point. Now if you see, if we consider the rotational effect of a couple, rotational means moment. So moment of a couple, this moment of this couple about any point, an interesting property can be observed. Okay, so now see here, there are three sketches, that is figure A, figure B and figure number C. So in each sketch we are taken couple. So this is force F, this is force F, okay, and between the perpendicular distance between these two forces will be D, small d. Then we are going to take point 1 here, okay, point number 1, and the distance between this force and point 1 is D1, and the perpendicular distance between this force and point 1 is D2. So D1 and D2 are nothing but the perpendicular distance between the force F and point 1. So this is D1 and this is D2. Similarly here, same sketch, F separated by a distance, perpendicular distance D. Now second point I am going to take here. This is the point 2 I am going to take here, and from this force to point 2 is D3, and from this force to point 2 is perpendicular distance is D4. Similarly, third sketch, same force F and F couple separated by a distance D. Now point 3 is here now. Okay, this is D6, perpendicular distance between this force and 3 is D6, and this is from point 3 to this force is D5. So in all the cases we are going to calculate the moment of couple about first point, moment of couple about second point, and moment of couple about third point. And in interesting property you can observe here. Let the magnitude of the forces forming the couple will be F. So this is F, this is F. In all the cases magnitude will be same, F, opposite direction and separated by a distance. Okay, now next, consider the moment of two forces forming a couple about point 1 as shown in figure A. Now see, first consider this sketch. I want to calculate moment of these two forces which are forming the couple, right? I want to calculate moment of this couple about point 1. So what is the moment? Force into perpendicular distance. Now there are two forces. Consider one by one. What is the moment of this force F about 1? So moment of this force about 1 is force into perpendicular distance. So force is F and perpendicular distance between this force and 1 is D1. Okay, so F into D1. Now see, with reference to 1, this will going to rotate clockwise. Okay, this will going to rotate clockwise. So moment of this F about 1 is F into D1, and this is plus. Now see, M1 is equal to, that is moment of couple about 1. okay, is equal to 0.1 is equal to F into D1. It is here plus. So F into D1. Then next force. What is the moment of this force? F about 0.1. So again force is F. Perpendicular distance between this force and 0.1 is D2 now. Okay. And with reference to 1, this again will going to rotate clockwise. Okay. Here you have to take a reference point and rotate, move on to this force. Okay, this is again clockwise rotation means plus. So plus F into D1, then plus F into D2. Now see, F into D1 plus F into D2. So common term is F, remove outside, it is D1 plus D2. So F, M1 is equal to F. What is D1 plus D2? Now see here, D1 plus D2 is nothing but D. Okay. So F into D1 plus D2 is D. So moment of this couple about 0.1 is what? F into D1, that is magnitude of forces into perpendicular distance between them. So F M1 is equal to F into D. Now similarly, now consider the moment of force about second point now. Now see this sketch. Now I want to calculate moment of this couple about point 2. Now point 2 is outside this forces. Okay. Now again what is the moment is equal to, again consider one by one. Okay. So first is this force. What is the moment of this force? Okay. What is the moment of this force F about point 2 is? So force is F. Okay. Force is F. Perpendicular distance between point 2 and this F is D3. And with reference to 2, this will going to rotate clockwise. This will going to rotate clockwise means you have to consider plus. So plus F into D3. Okay. Moment of this force about 2 is F into perpendicular distance is D3, and with reference to 2, this will going to rotate clockwise means it is plus F into D3. So M2 is equal to F into D3. Then this force. What is the moment of this force about 2 now? Okay. Now this is the force. This is the force, and what is the perpendicular distance between this force and 2 is D4. Okay. So F into D4. Moment of this force about 2 is F into D4, and with reference to 2, this will going to rotate anti-clockwise. Okay, this will going to rotate anti-clockwise means minus F into D4. Now see, so M2 is equal to F into D3 minus, because it is anti-clockwise moment, F into D4. So again F is common term, so D3 minus D4. Okay, D3 minus D4 is what? D3. Okay, D3 minus D4. Again it is D. So M2 is also F into D. Right. Same as that of M1 is also F into D. M2 is also F into D. Similarly, if we calculate moment of this couple about 3, this point now. Now point 3 is this side. Okay. Even if you calculate this, what we're going to get? M3 is equal to F into D only. So in all the cases, okay, so same couple, right? If you, the different points, so M1 we have 1.1 you have taken in between these two, 2 you have taken here, and 3 you have taken here, and calculated M1, M2, M3. In all the cases it is same, F into D, F into D, and F into D. So thus what it indicates, right? Moment of a couple, right? Moment of a couple about any point. Moment of a couple about any point is a constant, and it is equal to what? Moment is equal to what? Force into perpendicular distance between the two forces. See, force forming, which are forming the couple, and perpendicular distance between them. So F into D will be the moment of couple about any point. Wherever you take, the moment will be F into D only. Okay, so this is what an interesting observation you can note here. Okay. Next, last, we're going to consider what are the characteristics of a couple. Couple definition we have know, and moment of couple we have calculated. Then you can able to write the what are the characteristics of a couple. So first characteristic was a couple consists of, so to form a couple what is required, right? A couple consists of pair of equal and opposite parallel forces. So two forces must be required, right? Those two forces must be parallel, the magnitude should be same and in opposite direction, and those two forces must be separated by a definite distance. That is the first characteristic. Okay. Then second, we have seen that the translatory effect of a couple on the body is 0. So whenever there is a couple, there is no translatory motion, means there is no horizontal movement, there is no horizontal vertical movement, only rotation will be there. So translatory effect will be 0. Then third, rotational effect or moment of a couple. Just now you have calculated in all the three cases. The moment of a couple about any point, see, about any point is same and is equal to product of magnitude of force and perpendicular distance between them, that is F into D. Any point if you take, it will be F into D only. Then the effect of a couple, the effect of a couple is unchanged, right? If the couple is rotated through any angle. Now see, take this first figure. You rotate this, then calculate, right? Then calculate again moment. It will not going to change. It will going to remain same, F into D only. So another interesting character is if you rotate any angle, right, couple, the moment of couple is remains same. Okay, that is the effect of a couple is unchanged if the couple is rotated through any angle. So whatever angle you can rotate that, so it will remain same, F into D only. Next, last, the effect of a couple is unchanged. Okay, the effect of a couple is unchanged if the couple is shifted to any other position. Okay, if the couple is shifted to any other position. Now see, if I take this couple and I will move here. Okay, if I take this couple and I will going to move here and I will going to calculate moment of couple about 0.1, it will going to remain same, right? So if you rotate also, there is no change in the moment of a couple. If you shift the couple at any other position, right, the moment of a couple will going to remain same. Okay, so these are the characteristics of a couple. Okay, so let us stop here. So once again I will going to revise this. So today we have studied a moment of a couple. So moment means, remember, here onwards it is a rotation. Okay, so body will going to rotate either clockwise or anti-clockwise. So to form a moment, what is required? Force and a perpendicular distance is required. Important. Without perpendicular distance, even if there is an inclined distance, it will not going to rotate. We cannot say it is a moment. So force must be there and the perpendicular distance should be there between force and the point where you are calculating. So clockwise moments are considered as positive, anti-clockwise moments are considered as negative. Then we have seen unit of force. So unit of moment, that is unit of moment, will going to depend on unit of force and unit of distance, either Newton millimeter, Newton meter or kg centimeter, like that. Next we have studied couple. So to form a couple, two parallel forces, okay, of same magnitude, two parallel forces of same magnitude is required. Then only they should be separated by a perpendicular distance. Then only there will be a formation of couple. Then even it is possible to calculate moment of a couple. So we have seen the moment of couple about any point is same, that is F into D. So these are the things we have studied. Okay, so please go through once again. If any doubts are there, so feel free to ask. Okay, so in the next class we'll come up with some more interesting terms. So thank you very much for attending this session. So have a good day.